A manufacturing machine has an 8% defect rate. If 5 items are chosen at random, what is the probability that at least one will have a defect? So I received a question from a student who watched the video that's attached to this, and it's also available in the YouTube playlist for lesson 6. So you can review that if you would like to see it. But she had asked the question after watching that, why are we subtracting? And the reason is that whenever you do a probability of at least one of a certain type, it's way easier to use the law of complementary events than it is to figure it out piece by piece. So let's look at how we could lay this solution out if we were not using the complementary the law of complementary events. So first of all, 5 items are chosen at random, so n equals 5. And we want to know what is the probability that at least one will have a defect. So then if we say that x is the number of defective parts out of the 5 that are chosen, right? And then we say there are 2 possible things that could happen. You can either have a success, which since we're counting defective parts, that would be defective, and a failure would be not defective. So now that we've defined those, the little p that we need for our binomial probability distribution formula would be the probability of success or the probability of a defective item. And they said that this machine has an 8% defect rate. So that would mean the probability is 0.08. And the little q, which is the probability of failure, so the probability of not being defective, would then be equal to 1 minus 0.08 because they have to add up to 1. Success and failure, if that's all that can happen, they are complementary. So we would have 0.92 probability of failure. Okay, so what I've just done is I've figured out that we have a fixed number of trials, we have only 2 possible outcomes per trial, and we have a constant probability of success from trial to trial with independent trials. So this is binomial, which means I can find probabilities using the binomial distribution formula. Or in Excel, that's the probability that x is equal to x is found using binom.dist, where we put in the number of successes, the number of trials, the probability of success, and then we say false for cumulative. Now that's when we want the probability of an exact number of successes. Now with 5 trials, you could have 0 successes. In other words, 0 of the 5 end up being defective, or 1 or 2 or 3 or 4 or 5, right? So we can understand the problem if we look at what it would be like to imagine what could happen and do the probability distribution. So if there were 0 successes, then I would do binom.dist with 0 successes, 5 trials, a probability of success of 0.08, and false for cumulative. Now I can do that by copying this formula down so that I did it for 0 successes, 1 success, 2 success, 3 success, 4 successes, 5 successes. But the question was, what is the probability of getting at least 1? Well, at least 1 would be any of these right here. So the cumulative probability, or the total probability for that, the probability that x is at least 1 would be equal to the probability of exactly 1 plus the probability of exactly 2, and so on, right? So all I have to do then to get this is to add up all the probabilities except for the one where there are no successes. So I added up all of these, right? Okay, so that's how I get that answer. However, I could have just done this. I could have just said, well, the probability that x is at least 1 defective, right? The probability of that happening is 1 minus the probability of getting none defective. And so that would be, let me get this thing out of the way. That would be 1 minus, I'm going to put it down here. That would be equal to 1 minus binom.dist with just 0 successes in 5 trials with a 0.08 probability of success and false for cumulative. So just that 1, right? So notice I'm getting the same answer just by doing 1 minus the probability of none. That is a more efficient way of doing it. Well, it all depends on how you look at it. I mean, if you're really good with Excel and the binomial distribution by now, you can quickly create your binomial distribution table and just have done the sum formula on these cells almost just as quickly as doing this. I mean, I think it definitely takes more time. I mean, you can see how quickly doing this 1 minus, because you don't have to write anything out really to get the answer. You just type it right in and go for it, and doing that is really quick and efficient. So, as long as you understand what you're doing, you can find the answer using the law of complementary events. Otherwise, you end up having to create the whole table and then realize that you need to add up all of these probabilities because each one of these numbers of successes all qualify as one or more, at least one. So I hope that helps.